Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we look at convergence of a GP. So GP, geometric progression, also known as a geometric series, we know that it has a bunch of terms. So we know something like this would be a GP. If we start at 2, 4, 8, 16, and it goes on and on and on. So you're used to seeing GPs like this. The terms just get really big really fast. If I just kept writing the terms, they would get larger and larger and larger. So we say that this GP diverges. When we're talking about diverges, really we're actually talking about the sum. You see, if I were just to keep adding together all of these terms, as I keep adding terms, the sum of these terms here would just get larger and larger and larger and larger. It would approach infinity. But that's not always the case for a GP. The sum of the terms doesn't always get larger and larger and larger. Particularly if r is between, but not including -1 and 1, the sequence actually converges, which is the opposite. So an example of this, let's start with the same term 2. But instead of timesing each term by 2, we're going to divide each term by 2. So this GP here has a common ratio of a half. So a half is clearly between -1 and 1. See, what's happening is each term is getting smaller and smaller or closer to 0. So we started off with 2, 1. Over here we're 0.25, 0.125, 0.0625, 0.03125. These terms are just getting smaller and smaller, closer and closer to 0. So, because each term is getting smaller and smaller, I'm eventually going to get to a point where if I add on any more terms, it won't do anything to the sum. If I were to add up these two terms, I get 3, then 3.5, 3.75, 3.875, 3.9325, 3.96375. As you can see, each time I'm adding a term, it's adding less and less to the sum. If I keep adding more and more terms here, because each term is getting so small, eventually it's going to stop adding anything to the sum. It turns out if I keep adding these terms over and over again, it will get closer and closer to 4, but never actually reach 4. And that's what we mean by converges. This GP has a sum that converges, gets closer and closer together. As I add more terms, the sum gets closer and closer to 4, but never actually hits it. It's really easy to tell whether or not a GP converges. All you have to do is look at the common ratio. Here the common ratio was 2, which is clearly not between -1 and 1. That's why this one diverges. And this one converges because r was a half. Each time I'm taking the previous term and multiplying by a half. So because r was a half, this converges. It's as simple as that. But now you also know what it means to converge and diverge. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.